Okay, a balloon has been inflated with helium. Says the volume of the helium in the balloon is given by blah when r is equal to the where r when r centimeters is the radius of the balloon. It says find the rate at which the volume of the graph in the balloon is changing with respect to the radius when the volume is blah. So first of all, we want to find what will the radius be when the volume is that? That's the first thing we want to do. So let's do that first. No differentiation required. So we've got volume is equal to 4/3 pi r cubed. And the volume in this case we're told is 288 pi. It's 4/3 pi r cubed. So our first job is to find r when the volume is this. And then use that to find the rate of change of the volume of the gas. So I'm going to divide both sides by pi. I'll do that straight away. And I'm going to divide both sides by 4/3. Divide by 4/3. Here we go. So r cubed is going to equal, let's do this one in one go. So I'm going to have 288 divided by 4/3. Put 4/3 like that. And I get 216. Well, that's the cube of 6. So therefore, r is going to equal 6. Thereabouts, by the way. If you're doing complex numbers, then there is a different function, different solution. But we're going to just go with 6 because, after all, we're dealing with physical objects and not imaginary ones. So let's go with that. So r is 6. So now we've found that. Now we can say, right, okay, we want to find the rate of which the volume is changing, the volume of the gas. So the volume, the rate at which the volume is changing with respect to the radius is equal to, let's differentiate this thing here. So it's going to be 3 lots of 4 is 12 on 3 pi r, and that will be squared. There's our differential, which is equal to 4 pi r squared. R is going to be 6, so it's going to equal 4 times 6 squared is 36 pi, or 144 pi. Now, usually you can just leave it as pi. I'm actually going to work it out. So 144 pi is, what's that going to be? 452 and change equals, I've got 452.389. 3421. Now, we've got to write that as an answer. So I'm going to put, I'll just do it to 2dp. So it's 452.3, I'm going to call that 39. Now, this is volume in cubic centimeters. Volume, which is cubic centimeters, per radius, which is going to be per centimeter. And that's what I would write. So you want space between there and there. I didn't leave a very big space, but it's 452.39 cubic centimeters per centimeter. And that would be my answer.